All right. Hey, it's me, John Park, and I am here with Echo. Let me cut that. On John Park's workshop. So welcome. Here we are, Adafruit Industries, John Park's workshop, and we are live. So, hey, John K. Schaffstall, welcome to the YouTube chat, and welcome to everybody over in Discord. I also want to say welcome to the people in Twitch and Periscope and Facebook Live, although I'm not in those chats. Hello. So, hey, I'm hoping that my main camera that sometimes likes to shut off when it overheats won't do that today. It's getting a little warm out here in Southern California, but I've pointed a fan at it. A very noisy 120 millimeter AC, like PC cooling fan I had from 20 years ago when I used to overclock like Windows NT Pentium 2 machines. So yeah, I'm hoping this mic doesn't pick that up too much, but with any luck, it will prevent the camera from going out. Let's see. So I'm just noticing a distracting glare over there. I'm going to go fix that. I put some anti-glare on one side of my little display case thing here. If I slide that, that'll cut it. So we've got a fun show in store for you today. We're going to be building a little robot that's a bumper car bot. Yannick Murray suggests I put the camera in a bag of ice cubes. I think I've seen, this is a Sony A6300 that I'm using for that main cam. It's that one right there. Let me fix that. And that camera, I think I've seen people online putting big aluminum heat sinks on the back of it with the little LCD screen lifted out so that they don't overheat the camera. I'm looking at the lagged version of my own video over there on YouTube, which is going to drive me nuts. So I'm going to pop out the chat there and then it'll hide that. There we are. That's very distracting to see yourself from 5 seconds ago or whatever the delay is. It's not much of a delay. So let's see, I've got some delicious, delicious coffee. Some cold brew. And let's get to it. So first thing before I forget, coupon code. So today's coupon code is BUMPER. B-U-M-P-E-R, bumper, and that will get you 10% off on all items in the Adafruit store with the exception of gift certificates, subscriptions, and software. Everything else will just throw it all in your cart. Everything you want, with lots of cool, great new products this week and last week. If anyone watched the new projects last night on Ask an Engineer, I'm really excited about those little tiny plastic test points for clipping into PCBs, so you can hook test leads to them. Those I haven't tried them yet, but I'm going to order some. Those look cool. So in fact, let's jump from that, the coupon code, to that, which is the product of the week. I missed this part. And the product of the week this week is the Crickit. Yes, it's been Crickit for the last few shows, but I love this thing. I love this board. Here's one right here that I've got plugged into USB that we'll be using today. So Crickit board is that guy. And on top of it, this one has the Circuit Playground Express, which is bolted on with 6 standoffs, biscuit style. And we now have a few new ones coming out. So there's going to be a feather Crickit that lets you plop a feather onto there and use the Crickit as the expansion board. There's going to be a microbit Crickit. There's going to be a pi hat Crickit. Who knows where it'll stop? Will it ever stop? So Crickit, if you're not familiar with it, is a creative robotics something kit. I can't remember. Something construction, interactive construction kit. Creative robotics interactive construction kit. What it does is it's a breakout board for, in this case, Circuit Playground Express, that gives you a whole bunch of I/O because it has our little Seesaw coprocessor on there. So we get 8 analog in-out or digital in-outs over here. You can plug anything into it. I've successfully plugged in my Power Glove to that for just one of the flex sensors. We have 4 servo controllers on here. We have PWM servo controls. We have 2 motor controllers, which can also be, I think, a unipolar stepper or a bipolar stepper. We have another out that can be solenoids, electromagnets, like latching stuff. That's the drive section over here. We have a NeoPixel output that takes care of the level shifting from 3 volt to 5 volts. So that's very cool, and it makes your NeoPixels work exactly as planned and provides power, the 5 volts. And we also have a direct out from the A0 for audio on here, so you can plug speakers into it with the little audio amplifier that's on there. So, I don't know, I'm probably forgetting something. Oh, capacitive touch. Lamore did that last night too. Why forget capacitive touch? It's 4 capacitive touch outputs on there as well for triggering things. So, use the Circuit Playground Express as the brain to drive all this coprocessing goodness. And you can code it in Circuit Python. You can code it in MakeCode now. We've got the sort of beta version of MakeCode Crickit blocks, which is very cool. And also Arduino. So I haven't used Arduino with it yet. I'm right? I think we can. I don't know if there's libraries yet, but definitely CircuitPython. It's kind of what it's made for, and MakeCode. So that's the product of the week, and we're going to be using that today in our project. So let's see. Let's see, what do we want to dive into? Let's dive into, I actually want to jump ahead for a second into the little tools and techniques section and just show you a simple cardboard technique that is, I think, pretty helpful when you're starting to construct stuff with cardboard, particularly dimensional stuff. So let's head over to the workbench, and we will put on the overhead there. And I'm going to walk around there. I'm not going to forget my coffee. And I'm going to fire up the chat over here real quick. Ezra Sky says that I should basically pot my camera, take it apart, do silicone conformal coating on the electronics, and then I can submerge it. This is for the chilling in ice water. That would be a great project on its own. So let's, I'm just going to grab the YouTube link over here, and again, mute and hide that. Oh gosh, look out for echo time. So let's, I'm just going to grab the... Hi me. And let's see, am I logged in as me? I think I am. Let's pop up the chat. I think I'll pause that one there. All right, cool, we're in the chat. So let's take a look. I'm going to do a close-up of this view. Put me in the corner there. So I've moved my camera around. It's a little more centered now. So this is the technique. You've probably seen this in boxes that have dividers in them. And it's a dead simple technique, but it's really effective, especially if you need to make dividers for things. But there's other types of structural construction that you can do using this technique. And so let's just start with a couple of fresh slices here. I will just eyeball a straight cut there. And as you can see here, if I line these up right now, these are about the same height. So what I'm going to do is just simply go about halfway into the cut, and you should go the width of the thickness. In fact, that was terrible. Let's mark that off and do that properly. And you know what? I'm going to switch over to this little camera here so that it's even closer upper. So here you can see I'm going to mark off a width of the material thickness here. Cut this. Cut this. This is a tricky cut here. I don't want to go too far with this, and it's kind of a big blade. Might be better off with an X-Acto there. I'll just pull that out. And then we're going to do a similar cut over here. So we can take a look at these if we want them squared up. And I'm going to line up that width. Chop this out of here. And if you get 3 and 3, you can make what's inside of a typical box for carrying liquor bottles or wine bottles. And so these will now hook into each other. Now you can see I'm not all the way down, so I got to go a little deeper on one of them so that we reach all the way through. So let's deepen this cut here. So there are a few different techniques you can do in cardboard with slots and tabs. And this is a nice one here. So now you can imagine if we repeat that with other pieces, we can make, these aren't to size or cut properly, but we can make all kinds of structural components. I didn't mean to make a pentagram, maybe it's an anarchy A, where you can rely on, if I get these, this one's one of the thick ones that I cut before, but if we look at these proper sized ones, they won't wiggle too much, and you can cut it a little narrower. You can also go in and glue those. These are nice because they come apart, but if you take a look at just adding a little strip of glue here and here, it's actually a little nicer than just bending and folding single pieces and abutting them, right? So if we had to make this by butting things up, you actually get a little bit easier time of it using this technique, and you also get a little more strength and stability from that. So let that dry, and you have a nice little divider type of structure. So if you think about like shop organization or any kind of organization, if you want to put in really customized drawer dividers, you don't have to really go to the trouble of cutting foam or going into the wood shop or laser cutting something. You can actually make some pretty nice sturdy compartments using cardboard. I've seen some really nice storage stuff where everything's cardboard. The drawers, the cabinet that the drawers are in, the shelves for them to slide into. But if you have something existing, it could be a little tool carrier or a little organization box. I've got here, for example, a little Pelican case. Let me put that under, let's go under this camera here. So this is, we'll go ahead and just bend this for sake of expediency and getting that in there. But you can see if you just mark out, measure carefully, you can make some really nice little dividers to set screws or whatever you have into there. This camera looks dark. Why is it suddenly dark? I'm gonna risk everything and run up here and see if I can adjust the f-stop without looking. That's better. So that's the little cardboard tip of the week, is making your little slotted dividers using cardboard. All right. So Noam Pedro said thick chipboard to make dividers for the Adabot lunch. Oh, you did. That's too funny. We did not plan that, but Noam and Pedro say that they used some thick chipboard to make dividers in an Adabox lunchbox. That's very cool. Love it. Same slotted fittings too. Yeah, it's a cool technique. I have done it with laser cut stuff. In fact, I have one. I'm just remembering right over here. Hold on. Let me look inside this toolbox. Here's a sort of fancy one. This was for an escape room type of effect for a magician friend of mine, Michael Bories, and we had an effect using actually those little welder's glass LCD shutter panels, and we wanted to show the contents of these three little sections here. So if I put stuff in there, you can see. I've always got some Lego on hand to stick in somewhere. So we were hiding. This was in a cutout, and these were laser cut, but same type of idea. You can see I've got. These are all the same part right here, and then these two that they drop into. This was an extra one, so I have it in a drawer in a machinist's chest that I can use to organize something. I don't have anything inside of those in there yet. So there you go. That is the tool tip of the week. And now let's head back on over to the workstation, and we're going to take a look at our MakeCode minute. MakeCode minute. In fact, there's a bit of a setup for this. So let's talk about our project of the day, and then go back in time a little bit, and then the MakeCode minute will make sense why we're doing it. So let's see. This all starts with a robot that I built on the Make television show that we had on PBS, which is, I think, about 9 years ago now. Getting on almost 10 years ago that we did 10 episodes of the show Make TV. And I hosted a section called the Maker Workshop. And in one of the episodes, I built a couple of different types of small robots. One was this little solar circuit robot, and the other was, let me jump over to here. And I'm going to play this just straight off of my YouTube. Oh, I don't think we have audio with that. That's okay. So you can see here, this is a little kind of cockroach type of bot, a little beetle bot. And this one is all passive components. Actually, it's just a couple of switches and a battery pack. And so we have, oh, we got a bunch of robots there now. So let me rewind a little bit and pause. Oh, there's a line follower. Yeah, so we can pause right there. So you can see this guy has two antennas, kind of like a bug. And when an antenna gets hit, it essentially reverses the polarity of the batteries to one of these two motors over here. And so it reverses when it bumps into things. You can see it again. Reversed, and then it goes forward once that antenna is free again. So it's a pretty cool design. It's sort of based on this biology-inspired robotics, beam robotics. So fast forward now to today, we, Mr. Certainly says it looks like I filmed the PBS segment yesterday. I notice a lot less gray hair in that, but thank you. So now fast forward to today, and what I wanted to do was build a similar style of bot, which essentially navigates by bumping into things. It's dead simple, but it will drive in a straight line until it bumps into something, and then it'll reverse a little bit, turn, and go forward. And so this is not entirely dissimilar to how a Roomba works. It kind of bumps into stuff and rotates around and does these random patterns. So this is kind of a simple version of that type of a thing for what I'm calling a little bumper car bot. And so what I did was attach two TT motors, two of our yellow TT motors. And here's one of my prototypes of it. Attach two of these just with some double stick tape, or some of my early versions just use blue tape, each with one of these nice orange wheels and clear rubber tires, and then ran those into the two motor outputs, motor output 1 and 2 on our Crickit there, these two ends. And you can take a look here at early versions of me just driving them around. So check this out. So this is meant to be a tail dragger, but I was running it in the wrong direction. Now it's dragging a little, got a paper clip and a little ball bearing. I had a metal ball bearing that had an axle running through it from some toy. There you can see a wheel's getting stuck, so I'm trying to encourage it. Here I've improved it a little bit, and instead of the blue tape, which I think was catching the wheels, I've got, there's the original again, I've got the double stick tape going. So that is, that's just the basic principle of the tail dragger, which is if we have two motors, and this is actually similar to how a lot of airplanes, older airplanes or propeller airplanes work when they're on the ground, is that they have a couple of wheels and then they drag a tiny little wheel in the back that can just rotate on a caster basically as these two move forward. So if you move these two forward at the same time, we go in a straight line. If we favor one more over the other, we turn to the right. And if we want to spin around in basically in place, you can run the motors in opposition to each other. So it's a little bit like tank tread steering. So both of them forward, we can go right, we can go left, we can spin in place. And so that we're not having to worry about steering differentials and turning wheels with a servo or something like that, we just simply drag the butt on the ground. And it's a very, very simple way to make a little robot. I know that Phil is interested in doing a balancing bot, which is very cool. I've never built one of those. It seems like it'll be a lot of fun. You got to get like some weight up here and then use the accelerometer to counter the inertia as it moves. So that's the basics of the tail dragger. And it's a lot of fun to make those and just have it go. Now, what I did with that one is I just programmed it in MakeCode to have a go forward button and a stop button. Now, what we want to do instead for our bumper bot to behave a little bit more like our, I'm laughing because Yannick Murray said the haircut didn't change in 10 years. Really? I think I had it like kind of pushed forward back then. It looks weird to me now. It was a dark period of my hair. John asks about the surface I'm cutting on. It's a big cutting mat. I have it flipped over. It's got all the grid lines on it, but those were causing autofocus to freak out on one of my cameras, so I've just flipped it to the backside. But you'll find them in like a fabric store at a pretty large size and less expensive than if you go to a modeling store, I think. So yeah, check out a hobby store or a fabric store. You can get a large cutting mat for maybe, I think I got that for $20 because of the weekly 40% off sale at the hobby store. So the, yeah, self-healing cutting mat, there you go. Deadpool or Wolverine aisles. You guys are making me laugh. That's Mr. Certainly over in Discord. If you like puns, join the Discord chat. There's a lot of punsters there. So, and we love them. Okay, so now what I want to do, let's take a look over in MakeCode. Let's go here. So here's my cool green screenable MakeCode. I can chroma key through it so we can see what's going on. And now I've got to jump over and grab it. And what I've done, I think I showed this last week, is that I have added in the extensions here, I've added Crickit. So this is only in the beta. If you go to makecode.adafruit.com/beta, then this is going to be available. And if you want to know how to do this, it's in the tutorial I did for last week's project, which was our automaton using the cam follower. I used MakeCode and Crickit in that one too. So if you check out that in the Learn Guide, they'll take you through doing this. And this will eventually be out of beta and into the regular MakeCode, and then you won't have to type in a funny URL for it. Okay, so what I'm going to do is I'm going to move some of this stuff out of the way a little bit and build some of these pieces from scratch. So, excuse me. For our MakeCode minute, I'm going to try to keep a chunk to a minute here. What I'll talk about is using the accelerometer in order to change the direction of the motors. So let's look first. This is not the minute starting yet. I should really time myself. I don't have anything in here that counts in seconds. Everything's just like, it's 1:25 according to that clock. I need to bust out that big ninja timer. That's what I need to do. So okay, so let's go through some of this and then we'll build the shake part, a limited version of it from scratch. So on startup, I'm trying to set the volume not to be too loud, and I'm playing a sound, the magic wand sound. Then I am setting my two motors to be inverted. And I think I'm doing that only because I plugged in my wires backwards and was lazy. You won't necessarily have to do that, but you can invert what forward means on the two. It's kind of arbitrary on the two inputs if it's going to be positive or negative. So then I've got a little servo on there that I'm using as a little flag type of thing, and I've set that angle to 90 degrees, which is in the middle, so it'll go forward to 180 or backwards to 0, I think it is, yeah. And then I'm turning all the NeoPixels to yellow on it, which just shows I've kind of booted up and I'm ready. Then I'll press button A, and what I decided is you can do stuff where you click a button or just push it, or only on the upstroke or only on the downstroke. I tried playing around with those, especially for stopping the thing. Just pressing the button stops it, so you don't have to press and release successfully, which just means it's a little quicker to respond. It might be useful if you're doing like video games or things that need quick response. But anyway, there's a few options there for each of the buttons. There's a click, there's a long click, which is kind of cool. I've never used that. I don't know how long that click is. Up and down. And those are just using these two buttons that are on the Circuit Playground Express itself. So when I press the button A, that plays a beep and sets the NeoPixels to blue. It moves my little servo forward, the angle to forward, and then it just starts running both of the motors at 100%. On pressing B, we play a little beep beep sound. We stop both of the motors, which kind of disengages them, and then I change the color of the NeoPixels and move my little flag backwards. So now let's build from scratch. I'll kind of push this off to the side. Let's build from scratch how you deal with using the accelerometer. So here's our MakeCode minute. Inside of input, we have on shake, and this is just a sort of easy way to get at some of the accelerometer functions, which means if the values change rapidly on pretty much any axis, it will register that you have shaken the device. So if we look at the simulator over here, I can say on shake, let's change the color of the NeoPixels to red. So if I put that on and hit this little shake button, it simulates a shake, and it should turn it to red. Oh, I think it's failing for some reason. I don't know why. I don't have to actually shake it. Huh. Let's, all right, we'll ignore that terrible demo. We'll get rid of this. So what we'll actually do is tell the motors, so I'm going to, let's see, I need to add, oh, I haven't added the Crickit. Okay, so I'm going to add the Crickit package, or I had and I didn't see it. Here you see this little Crickit section. So now in Crickit, I will say stop motor 1, and I'll duplicate that and do a stop motor and switch that to 2. So that just means when it bumps into something, it would just simply stop. Now, I've done some other fancy stuff that we'll look at in the real version where I change the lights and make some sounds and stuff. But really, if you just want your bumper car to hit something, back up, turn, and keep going, we will first stop the motors. I think that's good practice rather than immediately switching them into reverse. Then I will switch them into reverse, which is with this Crickit set motor inverted. And I'll duplicate that. Now remember, since mine started out for whatever weird reason already inverted, this is switching them by saying inverted to on. And you know what? I'm gonna, let's see, can I pull everything out of this one? I think it'll favor this one if I get rid of that. Yeah, let's delete that one. Okay, now that they're inverted, I'm gonna run them. So under Crickit, set run motor 1, and I'll go to about, say, 70% speed, duplicate that, same for motor 2. And now I'm going to have it pause for a moment, which means it'll let that run. So if we do, let's say, a half a second, it's 500 milliseconds. Now it's going to back up for half a second. And what I'll do at this point is I'm going to duplicate my stop motor 2. And whether this is left or right will depend on how you plug things in. So I'll stop the second motor, and then I can run the first motor again for, let's say, half a second. And then I can put that pair of motors into forward motion again. So I'll reverse the polarity of those by doing inverted. And now we can run the motors. And you can see here you get to start duplicating stuff instead of getting it from the category over here. So I'm going to run both of these motors at 100%. And if you run them at different speeds, you're going to turn. So that, let me get that out of my face a little bit. That will give us the behavior of we bump into something, it registers, it's going to stop the motors, it's going to flip their orientation, it's going to run them at a medium speed backwards, it's going to stop one of the motors, run one of them on its own, which is what's going to give us this kind of 3-point turn backup kind of action. And then it will flip the motors into run in the other direction, and off we go again. So that is your MakeCode 6 minutes. It wasn't a minute. I checked. That is your MakeCode 6 minutes that will allow a cart with 2 motors to bump into something, register it, and back up and get out of the way. And it can keep doing this until it turns all the way around if it's in a sort of a U-turn cul-de-sac kind of thing. And we'll play around with that once we build the bot over on my workbench. So let's actually take a look at that in action. Let me see if there's any. Yeah, oh yeah, C. Grover says this would be a very adaptable to a wall-hugging maze-solving robot. Yeah, for sure. I know you can solve all mazes by always turning left, right? Isn't that the one of the ways that maze-solving robots figure things out? They eventually get out by doing that. I think that's the answer. I've never done that. Okay, so here we have. Let me get that out of the way. Okay, so here we have. This in action. So you can see it hits 2 boxes of LaCroix, it hits my shoe, hits the wall, shoe again, that's a move robot, and off it goes. So let's now now let's take a look at, I'm laughing at the jokes over in Discord. Let's take a look at building this thing. So, and then we'll do a real demo of it at the end. But I think we've got enough time to build one of these from scratch, which is a lot of fun. And you can build it from a lot of different materials, and there's a lot of different things you can do to build your caster in the back. You can use like real wheel casters. You can use the end of a deodorant ball. That's a pretty common one people do. You can buy purpose-built casters. We're gonna use a paper clip or a safety pin, I think, for ours. So I'm gonna head over to the workbench. Which view is that? Oh, now I'm confused. Oh, that's the one. There we go. Let's head over here and put this guy together. Yeah, if my friend Mark and his daughter Jane were thinking of stopping by to watch the show today, if you're here, welcome. And Jane has built some robots using, I think, Arduino Uno compatible boards and probably motor drivers. I'm not sure if she's gone directly off of there, but I think for anyone who's doing robotics in schools, you're going to really want to consider taking a look at the Crickit, just because of all of the things it brings into one neat package. You don't have as much sort of stuff plugged onto each other. So I think that for definitely educational robotics stuff, this is a pretty cool board to check out. So I hope you check that out. Okay, so here is sort of the finished bot. So we're doing this reverse cooking show order. So here's the bot I built yesterday. And you saw that I had a few different prototypes. I've even thrown some of them away because they were literally just like a piece of cardboard. But here's the one I'm going to pull apart for parts. And you can see there the idea was using a couple popsicle sticks to make our tail dragger, which I kind of like that idea. But we'll do it all out of cardboard. So what I'm going to do is pull these off of their double stick tape, which is great stuff. It works really well for getting these on here. We do have some bracket kits in the store. Especially if you're attaching to stronger materials, you may want to look at these little TT motor brackets. They're designed especially for it. So you can see we've got these two long screws that go through the two holes that are in the TT motor, and now we have four, I think M3 or M2.5, these are M3, excuse me, screw holes, and then screws and nuts to go up into a piece of wood, piece of aluminum, whatever you want. I tapped a piece of aluminum for one of these a little while ago to try to do something a little more stable. Same sort of idea. Obviously, that's sort of an overkill chunk of aluminum. But you can see I've tapped some holes in there so we can screw these guys into here. So let's now, is this camera? It is. Okay, so now let's take a look. In fact, let's make that one the big one. At constructing that frame. And so what I decided to do was, I've had a bunch of these sort of small shipping boxes. These are the ones DigiKey sent me, actually. I cut off a bunch of their flaps to make that wheel, one of these sort of drum wheel guys last week. And so I had like 8 flaps left over, and these are a pretty good size, I thought, for doing our little bot. So the considerations that I had for this were the balance of it. You want to be back heavy. What you don't want is the thing tipping forward and sort of scraping along in its bumper. So if you simply orient the TT motors this way, all the weight is right here in this metal motor. This is just plastic gears, and it's pretty darn light. So if you look at that, when I hold it in 2 fingers, it just keeps wanting to drop. So that's where the weight is. So we can keep that a little bit back. And then let's pretend those are on there using some double stick tape. Then we're going to have a battery pack. So here's a 3 AA battery pack. I've got another one you can see mounted to the bottom here. And so my idea is I wanted to keep the center of gravity low. This is not a top-heavy robot at all, but there's also no reason to put the battery pack up on the top. It's either going to be hidden underneath the Crickit and Circuit Playground Express, which I do want visible, or it's going to be on top of it, or back here, which would be too back heavy. So I figured just sticking it underneath means that you'll be able to still access the batteries, and it was one of the reasons I wanted to use this size of piece of cardboard. Is it's big enough to actually fit the battery pack in between without anything bumping into each other. So that's the strategy for sort of where you're placing things. And it's a good thing to mock up. And what I'll do is get the thing roughed out, and once I have the battery pack with the motors and wheels attached, then I can play around with the placement of the Crickit and Circuit Playground Express to get my weight not to be too far back. You can see that you can almost find a balance point here right now where it would stay. So what I did with some of these at first was built up my little platform here to hold the two motors. And you can see I've glued two pieces of cardboard to each other with opposite grains, which gives you a lot of strength and stability. If you have the corrugation just running this way, it's going to flex and bend. All right, so here's the grain of the corrugation flutes, and it's going to flex and bend like crazy, but in this direction it's strong. So by layering and laminating two pieces of cardboard, you get a really rigid piece. So I did that. I attached these two guys, and then I decided to figure out my little outrigger here for the tail dragging part. Totally valid way to do it, but I also wanted to see if we could make it just from a single piece of cardboard pretty much, which is what my final design was. So, sorry. So here's one of my earlier ones. I think this was too short, so I had to tape an extra piece of cardboard onto there. And this is mostly for aesthetics. You don't need a V back here to poke a tail dragging piece into, but why not? So what I'll do is, we'll make a fresh one here. And just so you can see it, again, this cutout here is mostly aesthetics. I also needed a place to pass some wires through, so I've got a little triangle there. And you can measure the center line out. And I didn't just come up with this out of thin air. I did this by placing motors and taping stuff on, and then marking stuff and cutting it. But this is what ended up working out well. So I'm going to go with that one. And then to cut this, you could use some scissors, or you can kind of carefully come in here. And this doesn't necessarily need to be angled. It was kind of an aesthetic choice. But I figure since we're going to be hitting things at angles, we might get a better we actually want to whack into stuff fairly rigidly so that we get the accelerometer shake. And so I don't want to hit stuff at a corner and kind of sloppily turn. So this seemed to work well for that. So now you could use a ruler a straight edge to try to get those nice, but they aren't super important to get exact. So I'll just do it quickly here today. How's the sound? Do you guys hear that little annoying fan back there? It's driving me crazy, but I suspect you can't hear it. Mr. Certainly says the feather plus Crickit. Yeah, so that's right. That's coming out. Feather Crickit. That means you'll be able to stack other wings on there, which is pretty darn cool. You can make a little roving boombox with it, with the Music Maker feather wing on there, some visualizations with all those NeoPixels. What else? You can do some cool stuff. All right, so now let's take a couple pieces of double stick tape. And for this, what we'll do is we want to line these up with each other pretty well. So we can do that either by finding a point that's going to be the same on them, or I think I'll go ahead and decide where one of them's going and then measure and mark that point across to the other side. Nice thing, I've got the corrugation running this way. If you've kept most of your cuts straight, you don't have too much trouble finding this perpendicular line here. Okay, so that's going to be the ends of my motor, there and there, like so. So let's get some scissors out for the double stick tape. There's a few different kinds of double stick tape. There's probably plenty. This is like a 3M one that I got a big roll of just online, like on Amazon. I like this one because it's fairly dense, and so it doesn't tear and leave behind all that marshmallow fluff kind of stuff when you remove it. It stays intact. The adhesive gives before the material itself, which some of the softer, squishier double stick foam tapes don't do. But like I've said, get double stick foam tape, not just double stick tape, because being able to conform into the surfaces really helps it stick if your surfaces are a little rough or uneven. So I'm just lining up a feature on the motor like so. These, by the way, are just a press-on little wheel that's got the same internal shape as this axle here. It's a little through axle. You can use a screw. I don't know if I have any around here. You can use a screw to screw it into the side of the axle. It's got a little hole in it. All right, so there's one of them. You want to keep this sort of straight forward. You don't want them to toe in or out or anything like that. It's not vital, but oh look, okay. So you can screw this up, right? You might have put it on the wrong side. It doesn't make a huge difference, honestly, since we have an axle on each side. When I see what I've done here, I don't know if I did this way on the previous one. Yeah, I did. So if you see the two motors are kind of mirror images of each other in that the wires are running both pointing on the inside. What that means is that you may find that you've got to stick them into the motor outputs on the Crickit in opposite directions or the same. I think what I ended up with was the same. Even so, in this orientation, I put black on the left and red on the red on the right in both of them, and they ended up doing what I expected. So you don't want to make your life harder by having to run one motor in forward and one in reverse to go forward. And luckily, all of that you can change just by inserting these in the opposite direction or the same direction into the motor terminals. Okay, so press that on there, and that's pretty good. Now, if you were worried about these popping off, you could certainly cut a couple pieces of cardboard, probably with the grain running this way. Not this guy's a bad floppy example. Here's a piece. Right, so we could take a piece like this, stick it on there, and that would give this a lot of rigidity. I have found that it's not an issue with this spot. And I even stepped on it once, and it survived pretty well. It just popped the wheel off. Don't go stepping on your robots, though. Okay, so you can see now we've got definitely rear heavy because of the wheel there, or the motor rather. So now what I'll do is put in my battery pack. And I think I'm going to steal the battery pack. Do I want to steal that one? Yeah, I'll use this one. This guy's a little big, but he's got this switch, which is pretty cool. I think he's got power. I hope he does, because I don't really feel like... You know what I'm going to do? I'm going to boot up the Crickit with it real quick. And it lights up. That's good. Okay. These are cool weatherproof ones. We have them in the Adafruit store. They screw in place and have a gasket, which means that they're a bit more work to get at when you want to change the batteries out. Okay, so for this, I think I will maybe favor it forward a little bit. You can test it up top so that it's not too rear heavy. Something like that. And again, you can use screws if you want. This has little tabs for screws, mounting points, but I'm going to use double stick tape just to make it quick. As I've matured in life, I've come to appreciate and embrace double stick tape and hot glue a lot more than I used to. Okay, we'll keep that pretty well centered. And you know, if you're a teacher and you're doing lessons using this type of construction of a little cart, have your students play around with different offsetting of parts and see, does it make a difference if the batteries are heavy to one side? Does the thing tend to turn or favor a side when it's driving? There's kind of interesting things to play with that a lot of times we do just by intuition, having played with these sorts of things for a long time. But if you're new to this stuff, you know, what design decisions do you make based on the weight and balance of the thing? All right, so here you can see I've got that little hole there that I can pop my motor leads and power jack through, plug through. Okay, so it's still rear heavy, but not terribly so. So this actually, I've put the little rubber bumpers that come with it on there so I can kind of rest it there. And you can see if I get a little too far forward, it's going to tip the balance. So I want to make sure this guy stays here so I can sort of center this. That looks kind of cool. I'll sort of center this in the middle here. And so I'm running the, I don't know if this is the best decision. Let's see if my power cord is long enough for this. This one's not. This one I could lengthen, but the other one I used, I was able to reach. Let's see, can I? Yeah, I don't have enough to really cut that out of the way, do I? Let's see. So this is cardboard, yo. Got a lot of options. I can actually either come from the front, cut a little hole in there, or reverse this. I don't like any of those options. I'm going to reverse my battery pack. So this will sacrifice the tape often. This one, we'll see. It took a bit of paper with it, but I'm going to run this up here. It seems like it's stuck well. If it falls off, we will retape it. And I'll just put a little notch and run this power in through the side here, I think. The power of cardboard. Makes it easy to change your mind. Okay, so that's how we'll run power in on this guy. And I want to keep these things out of the front because this is a functioning and active bumper that we're going to have here. Okay, and again, you could drive some little screws or nylon screws and standoffs into here. It should be pretty nice. I'm going to stack a couple of pieces of double stick tape just because I have those bumpers on there. And voila, double thickness, double stickness. That used to be my hip-hop dancer name. I didn't just say that. Okay, and it's on there? No, we need one more. Triple thickness, double stickness. I guess I could have put cardboard in between the sandwichy layers. Okay, I like that. That works. Tuck that in over there. So now we'll run our two motors, and you probably want to pay attention to which one's the left and which one's the right, but that's only if you care a lot about which one is which in software. So I'm calling the left motor motor 1, and we've got that little screw terminal there. Let me zoom in for you. So you can see that a little better. And it was nice to find, as I was putting these together, that there is enough clearance between the wheel and these little header pin sockets to plug in without hitting anything. And I think I'll keep these in the same. I think this is how this one was going to work, is that I'll put red on the right and black on the left for both of them. I'm going to wake up my iPad. We can hear it. You can hear the fan, huh? Tell you one thing, when I did that Make TV show, I did not need reading glasses. That's something that has changed in 9 years. I've always got to back way up when I'm looking at stuff if I don't put on reading glasses now. All right, good. So that might rub the wheel a little, but we can also tuck it across these terminal blocks here, or tape it down, or whatever you want. Make a little notch in the cardboard. So it looks pretty good. Now, what am I forgetting? Something to tail drag on. So, like I said, you can use a roller ball. You can use beads. I've tried. Here's one that PT Phil Terone came up with for some project, which was. See, Grover can hear it too, huh? Should I tempt fate? And let me turn off that fan for a little while and see if the camera dies. Why not? It got a little windier outside, so let's see. I'm sure that I could use a quieter fan than this one too. Where is the switch? All right. Ah, God, that's annoying. Okay. Yeah, back when I used to overclock computers, I started to realize that I hated being near my computer, and it was because of all the stupid fans, especially the little high-pitched ones that were meant to cool off your hard drives. So here's an idea that Filtrone had, which was gluing beads, or I've got these kind of ball bearings hot glued to the bottom of a straw, and that slides over surfaces really nicely and can act as a pretty good caster. You could also slip, this pencil's too big, but you could slip like a wooden dowel or something else in there if you needed to make it a little more rigid. So that's definitely a way you could do a little tail dragger, maybe just glue that into that slot there. The method I used for this one is very fast and expedient, especially if you're doing this like in a classroom setting and you just want to, cannot hear it now, good. It's helpful when you turn stuff off. Is a paper clip. So this is a really fast and easy way to do it. I think I've run out of paper clips in my workshop, so I'm not going to do that one. On this one, I will show you its predecessor, which is the safety pin. So you may know from watching this show I love safety pins, and I've usually got a few stuck to a magnet on the side of my workbench because you often need a very sharp little pokey thing, but it's got a built-in, you know, protection, little cover there. So I'll sacrifice this one for a tail dragger, and all you got to do is get it pretty close in depth to the sort of throat of the safety pin, so it can turn a little bit but not sort of flip itself too far around. And if you poke it up through sort of the middle there, just a little ways, and then close it off, now we have a little tail dragging thing that's got very, very minimal friction. It can rotate a little bit, sort of like a caster. It makes a scrapey noise, which you may have seen in my videos, but it's a pretty decent, quick, expedient caster. Let's fire this up and take a look, because that's basically all we need to make the bot. Now, one thing I did differently, let's actually add this one feature, which is so that I can bump into low objects. And what you'll see if I zoom the camera out is I've got a piece of 2x4 over here and a little 1x over here. If we have too high a bumper, we're just going to slide over that and hit against the battery pack or something like that. So I wanted to put a little bumper on it. We got this little curve here, and so we'll use this technique I showed in one of the earlier cardboard technique videos, which is to make a nice little joint. It's kind of a lap joint here on a piece of cardboard. So what I'll do is I'll measure a piece that is going to hang down enough to be useful. Maybe a little longer than that in this case. And it's got to be big enough to fit around this, and we'll end up putting a curve in it too. So let's try to get a moderately straight cut here. And even with a sharp blade, moderately recently changed blade, I do find give a couple of cuts through without trying to really drag your way through, and your cardboard will cut a little nicer. And so we're going to go, I'll leave it maybe a little long at first, because when we bend it, we'll lose some length to it. So I can wrap this around something, something maybe a little smaller diameter than that. Roll of tape is good. Here's a roll of gaff tape. You can do like so to put a little bend into it. We don't have to get too fancy and do the tracked vehicle thing with this. Well, you could. And you know what? I'll leave it a little long. How about this? Will be like little fenders for my wheels there. So now what I'm going to do is cut a little, let's get the straighter side. I'm going to go through the first face and the flutes, but I don't want to cut through the second face. So you want to go real gentle. You can now feel up that we're going into the flutes a little bit. But we'll kind of end up tearing those off even. So let me switch to this close-up view. can see here, oh, let me zoom, do an autofocus. So you can see here, there's the front face, and now if I was able to cut through those flutes, this should peel off nicely. If not, I can go back in. Yeah, I didn't really get those. Let's go back in. And so you just want to avoid getting through the bottom side there, which is that second face. So don't cut that off. And it should just peel up and out like that. So, oh, you could not hear it before. I misunderstood. So the fan wasn't bothering you. Okay, good. Well, that's good to hear. Maybe I should turn it on again before it kills that camera. We'll see. So this is actually a good question for the woodworkers in the audience. What kind of joint am I making here? Am I right in calling this a lap joint? I'm not quite sure if that's the right name for it. So what I'm going to do here now is just put a little bead of hot glue. You could definitely do this with white glue as well. You're just going to have to hold it or clamp it a little longer. You can clamp it with some rubber bands or something maybe. And now we'll try to sort of center this. And this is being a little bit fancy with this. You don't necessarily need to do this way. You could put a bumper on this other ways, including just at a right angle gluing into it, or shoving skewers through it and hot gluing those in place so they don't wiggle too much. But this, I kind of like the aesthetic of this clean edge that we get, like that. And let me hold that a moment longer. Picking up a screwdriver along the way. So there we have it. We got a kind of nice little bumper there. Let me switch back to this bigger camera. And what we'll do is, in a rare thing on John Park's workshop, I'm going to clean off my workbench here, and we're going to let this thing drive. So I'll block it from one direction. I'll probably hold a piece of wood, but let's get this clear. Oops, something just fell. Try not to throw knives. Here, we'll go to the watch a guy clean his workbench cam. There we go. We'll take this one out of the way. Oh, so, and the one thing that I have in there that I forgot, two things actually, are the speaker. We'll run this one separately. I've got a speaker in here for sound, and I've got my little servo motor for this flag. So we'll run that guy. Actually, we maybe can actually do bumper cars now if these guys will behave. I haven't tried that yet to see what happens when they bump into each other. If the sensitivity of the accelerometer settings is set properly to make those go off. All right, so here's our Virgin Voyage. Let me pull this sheet out of the way. Actually, you can see it a little better with it there. So here we go. Let's see. We've got, turn on battery power down here. Okay, so this one won't make any sound. We'll use that one in a second. But let's try just the, whoa, going this way. So we got to reverse the, either reverse that in code, or it'll be faster right now for me to reverse these. So we want, that always happens. I'm glad you saw that, because be prepared. That's probably going to happen to you. Which way is forward and which way is backwards? So if you put red on the right with the motors oriented in the direction they are, this apparently was forward. But you can flip these motors over, so it's easy to change what things mean. I'll show you, actually. If I start this up right now, it's going to spin in a tight circle, probably. Whoa. Why not? Did I not reverse that? What just happened? That's going this way. This going. Did I just do this? I took them out and put them in the exact same order, didn't I? Black goes on the right. Jeez. Live television, folks. Or whatever we call this. Live internet. All right. Now we'll reverse them. And that actually would be kind of a handy thing to program into the slide switch on the Circuit Playground Express. You could have a variable that just decides what means forward and what means backwards for the motors. Or get fancier than that, you can put off-board switches. Because we have some free pins on the Circuit Playground Express and we have 8 I/O pins on the Crickit board, you can make yourself some little knobs or selectors for things like motor direction, which would be pretty cool and a fun thing to figure out how to program using either Circuit Playground Express or MakeCode. These wheels, by the way, they pop right off, and that's probably a good thing to do when you're trying to plug all those motors in, is just pop that guy off. It's too late for me now. Okay, so let's, one more time. Ready? Okay, he wants to go this way. Yeah. Not bad. It's working pretty well. I think the, see there, I'm a little too, it didn't shake, right? It didn't bounce because I was moving a little bit. So it definitely works better on a rigid object that doesn't give too much. But I think the bumper gives a little bit of a bounce to it that also helps it feel that shake. All right, so let's stop it. Whoa. I'll show you this one. This is the one I made earlier, and now this one has, I'm going to zoom in closer, the speaker on it, and it also has this little, I just glued a kind of cocktail skewer pom-pom thing on here to make a flag. But what you'll hear with this one is we get startup sound. That's forward. So watch that little skewer. I'm going to put it into reverse, or stop when I stop it. Does this, goes a little beep beep. I've also got the NeoPixel colors corresponding. And now I'll just shake it. Stop that. He's run amok. Turn him off. All right, let's try this guy. I think his batteries might be going because he was acting funny. Yeah, he's a lot slower, you can tell. Shake. All right, let's try these in battle. It's fun having two of them. Yeah. More wood. That's what we need. Oh, that one's going off to knock over coffee and glue guns. Get back here. Let's make a triangle arena. There we go. This guy's totally winning. Let me zoom out. He's trying. Get over here. I don't think anyone is ever going to win. Oh, wait, this guy's got up under this guy. Oh, now he's confused. Perfect. Look at the mess we're in. He's trying. It's just like real bumper cars. This always happens. This is too fun. Will he ever get off of him? It's like babysitting 2-year-olds. Bumper bot wars. Yeah, we need to arm them now. All right, get off. Yeah, I certainly... Oh, look, he's like a wedge, man. He gets up under that guy. Go, go, go! Oh, he doesn't have... Oh, his tail has fallen over, so he doesn't have much angle there. Well, he's slowly pushing that guy. Can he get him knocked over? Let's zoom in. This is too dramatic. Can he get him? I'm going to give him a little help. Yeah! Victory! All right. That turned dark. I'm sorry, but yeah, that's kind of what happens with these things. All right. So I hope you enjoyed that. I sure did, clearly. Those are the bumper what do we call them? Bumper car bots using the Crickit and Circuit Playground Express. A really fun project. You can come up with a lot of different things for decorating it, adorning it, weaponizing it, making it friendlier perhaps. You could do a lot with sound on it. I just have it doing some beeps, but certainly with Circuit Playground you could play back wave files, which would be pretty cool. If you see some of the videos that PT and Lamore have been posting, using sound as cues for their lunar rover and or Mars rover and some of those bots. Really exciting, the kind of stuff you can do with what are fairly simple to create but sophisticated in their functionality little robot projects using the Crickit and Circuit Playground Express. And now we've got Feather and Microbit and Raspberry Pi coming down the line. So I'm really, really excited about the Crickit, and this project in particular has been a lot of fun. So thank you guys for stopping by and hanging out with me in John Park's workshop. I'm gonna hang out in the chat for a little while after the show if you've got questions or want to make suggestions. Before we forget, I want to remind you that the coupon code this week is BUMPER, B-U-M-P-E-R, so you can go grab a Crickit. I don't know if they're in stock at the moment, but get yourself a Crickit, get yourself Circuit Playground Express, some motors, load up your cart with good stuff and get 10% off of it, with the exception of software subscriptions and gift certificates. So that is going to do it for the show. Head on over to, oh, that didn't work. That was supposed to be Discord, and it went crazy, didn't it? Wow. Well, welcome to the Matrix. Oh, here we go. There's the Discord. Come on over to the Discord chat. I'm also over in the YouTube chat, but that'll be shut down when the show turns off. So thanks, everyone, for coming by. I'm John Park for Adafruit Industries, and this has been John Park's Workshop.